Trickiest bit about this question is going to be explaining clearly why we're necessarily getting the smallest possible difference, justifying it as we go along. So I'm going to start by writing A, B, C, D minus E, F, G, H. And A is going to be bigger than E, so the first number is going to be bigger than the second number. Now, to make the difference as small as possible, set A equal to E plus 1, just one away. Rather than going like 7 and 2 or something like that, we want them to be as close as possible. And then have B less than F. Difference then will be less than 1,000. Okay, now let's think about how we can make the difference as small as possible. To make it as small as possible, make B, C, D as small as possible. Because we know that A is going to be bigger than E, so we want to make it like as low as we can. And so we can make it 1, 2, 3. Remember, we're using the digits from 1 to 8 here. And then FGH as large as possible. So it's going to be 8, 7, 6. This leaves 4 and 5. Let A equal 5 and E equal 1 to satisfy A equals E plus 1. So this gives 5, 1, 2, 3 minus 4, 8, 7, 6. Which is going to give 247. This is the smallest difference. Okay, so I feel like I've done enough justifying along the way. Let's just like look over it one more time. Now we set the problem up. We said A has got to be bigger than E to get a positive difference. Make it as small as possible. We're going to have A and D as close as possible, so just differing by 1. And then B is going to be less than F, then we'll get a difference less than 1,000. And then so basically we want to make this number as small as possible and this one as big as possible given that these conditions from before. So use 876 and 123, put that in, subtract it, and we get the smallest difference. Okay, I think that's enough. Well done.